I'm going to talk about the anomaly detection in Go. Yeah, first, like a disclaimer, we can skip that. And who I am, I'm a researcher on one of the projects in the Intel Labs. My name is Michelangelo, and also the cloud engineer. I'm working research on the various telemetry tools, cloud software management, and scheduling problem. And when I'm now a researcher on Intel Labs, previously I was a Python and C developer, now mostly doing things in Go. OK, what's about the stack? Our primary thing on the Michelangelo project was about improving I/O of the Linux OS. And we do a lot of work, but to compare different results, we need to collect a lot of telemetry from the various resources. Probably most of us know what is the telemetry. It is a process when you are measuring and collecting data from the various things around the stacks, and you are storing them in the database or any other source. Yeah. And actually, what we are collecting, because we are doing a lot of the significant changes on the kernel, especially in the I/O space area, we need to collect nearly everything from the very low-level data on the CPU up to the specific up to I/O namespace, disk resources, and lots of the things around the KVM. And this was, and after that, we were storing everything in the InfluxDB. But we found the problem that because we were collecting data very frequently, because we need to prove results that actually our changes were significant for the I/O scheduling and some other things, we collect a lot of the traces, syscalls, application data, hardware data, and the OS data. And we end up, after one day, we collected about 1 terabyte data, of course, including some metadata. That was huge, because that was the first day when we were running experiments to try to compare the vanilla Linux kernel with the normal kernel. And we tried to look very much deeply in the data. Actually, we take a look at the data, and most of the data was very boring, because we're nearly static. There was a 20-20-20 and a 29-20. We'll fix it. How are we going to fix that? The first was a basic fix. Yeah, we can just remove the sum collectors. We don't need them. And we can just try to, but actually, we will not do. For sure, we will not going to do, because we need to have full information from all across the stacks. And the another thing, yeah, maybe there is some statistical method, then we can use it. And yeah, we were looking at many different resources. And actually, yeah, probably the simple thing was just like use the anomaly detection, where we are looking at the only outliers, and you're trying to look at the whole observation, and we're trying to take a look what actually it's very important in the data set. And of course, by definition, in anomaly detection, it's translating to the problems, just like software misconfiguration, unexpected software behavior, or hardware or software errors. Then we can easily find out, actually, are we improving or we are not improving our stack. The first method that we actually use is the TQ method, which is the very basic method. It's nearly statistical method from statistical books that you probably done on your statistical course on IT college. And the method is about to reduce the data amount of the data that needs to be transmitted, and you're looking at the specific part of the data, and you are removing not really interesting data, were mostly statistical. Yeah, it kind of work, and we're trying to do this, but there was one problem with this method. Actually, that's you need to specify a window size for the collection. And then we realized, actually, that we can only take a look at we can only take a look at the very short time of the data. Yeah, that was, of course, better, closer, and warmer. And we were fixed part of the problem that we have, but actually, it doesn't work well. And later on, we look at the more sophisticated ideas. We take a look, we try to benchmark things, and then we try to implement. We find out that there is a ESD method, and I don't want to talk about this method, how it's working, because it's mostly more complicated. It's close to the data science, but method is really cool, and you can look at the short time of data and at the very long time anomaly, because it's when you're collecting data by the 1 hour, it could be a long time. When we failed on the Tukey method, we fixed everything with using ESD method. And we said, yeah, that's it. And actually, that was working really well, and we were able to deploy the anomaly detection processor in our stack when we can feed all the data to the anomaly detection processor and push it to the database. At the end, we take a look at the data, and actually what's quite cool. It depends. This is not normal things, but if you look at this data, you can see that from the 623 samples, we remove most of them, and we end up with 89, and we preserve the shape of the data. Then we are OK, we are using the quiet compression, and actually, we have a lot of the space for another experiments on our cluster. And that's all. Yeah, we fixed the problem.